A particle is on a slope as shown. We want to find the components acting on the particle horizontally and vertically, and parallel to and perpendicular to the slope. Very often when we have particles on slopes, we're interested in the parallel and perpendicular components, since any movement that will occur will happen along the line of the slope. It therefore makes sense to have the forces in this direction. If we consider horizontally and vertically first, here's a vertical, and here is a horizontal. Clearly the W acts downwards vertically in any case, so it's the R that we need to resolve. If we consider this as theta, we can see we have a Z angle here. This angle therefore is theta. Since R is a normal reaction force, it acts at right angles to the slope. It follows that this angle must be 90 minus theta. And this is a right angle, so this angle is theta. And so the component of R in an upward direction is R cos theta, and that acts upwards, and the weight of W acts downwards. If we now consider horizontally, the only force acting is the component of R in this direction, and that must be minus R sine theta. I've just used the minus here because I put my arrow to the right and the force is to the left. If we now consider parallel and perpendicular, it's the W that we need to resolve into two components, parallel to and perpendicular to the slope. We form a triangle here. We can see this angle must be 90 minus theta. Therefore this angle is theta, and the component of W that is in this direction would be the cosine, since this is next to theta. The other component would be the sine. Since we deal with many problems of particles on slopes, you should get very used to this resolving, and it's worth looking now to see that W cos theta is the perpendicular and W sine theta is the parallel. So if we look at the parallel situation, we just have the W sine theta, the component of weight which is trying to pull the particle down the slope. Perpendicular, we have the R which is acting upwards, take away the W cos theta which is acting downwards.